Hello, I'm Robbie Clark. Welcome to my workshop. This is a Friday afternoon. It's about 14.5 degrees C in the workshop at the moment, so that's not too bad. Could be a bit warmer, but there we are. Anyway, I'm starting a brand new project, which will probably mean a lot of work on the milling machine. For this particular one, there'll be a little bit of work on the lathe as well. So I hope you'll come along and join me for the adventure. I was aiming for 3 inches or 3,000 over. I'm more than happy with that. It's not an absolute precise length. As near to 3 inches as I could get it, because my measurements are actually going to be from the centre anyway, so I can adjust for that. With the next job, I've got to drill a couple of holes in the piece of stock. I've already marked some positions on here. There's, if you can see, there's 2 inner lines here, and I've got a spot mark the end of the material as well. I've already found the centre of the piece of material, and the y-axis is locked, so I will just sort of double check the positions though. Just put that down in, make sure that's okay. And here I'm using my extra thin parallels in here, so that there's no danger of drilling into good ones. So that's all in position. I've got that tightened into place. Just bring the pointer down and I'll just check the position. It should be spot on because it's already been locked in place, so that's fine. Now just got to bring that along to the line with a little bit more light on the subject. Yep, that's fine. We'll just switch the pointer over to centre drill. As I say, this first one is just literally, I've just got to put a little witness mark, if you like, at that point. It'll become apparent later what that's actually for. I'll move that and put the pointer back in again. I'll bring that along to the next mark. Very squeaky handles on this. That's okay. Replace with the spot drill, the centre drill. Some oil on. Okay, and in with the final drill. This is a 7/32 drill. Okay, so out with this one, then back with the pointer again, and along to the second position. So, get in with our centre drill. Well, small drill first. And back in with our 7/32 drill. That's it for the holes being drilled. The next job is to put my collet chuck in with a 1/4 inch end mill and cut a slot across here. You won't be able to see the markings on it, so I've got to bring the slot up to a line here, and I've got some other markings here which you won't be able to see. I'm having trouble seeing them myself actually, but I've got to bring the slot down in this direction as well, not quite all the way down to this mark, but all that will become clear a bit later on. I've swapped the drill chuck over to a collet chuck with a 1/4 inch end mill in place, and I've got to just machine across here to make a slot. I'll just show a bit of this, and no point really in showing you all of this. I'll bring you back at the very end of machining this. If you saw my video on making the little toe clamps, I showed a lot of that machining anyway, so I think to show all that again is going to be rather boring for you, so I'll just start this off and then bring you back a bit later on. I'll just bring you back to the last bit. Already broken through, and I've brought the cutter down to this end to my data marks here, and I've just got to bring it back this way to the marks at the other end. That's it. Cutter up out of the way. There we are. So now there's a bit of deburring to do now, but I've brought the slot exactly where I need it in both directions. So just a lot of deburring and cleaning up now. And then on to the next sequence. I've moved on a bit with this because the next stage along required quite a bit of filing, manual filing, and I thought that might be a bit boring to watch, and I really needed to concentrate to do it. Now I'll show you the bit that I've filed out here. I think by now you're going to guess possibly what this is, but what I want to do now is to round both ends. What I did try was the old method of using filing buttons, clamping, in fact just clamping one on each side, and then filing, I don't know if you can see all this, filing around the the part. It didn't work out too well for me. I think what people often do is would be a hole drilled in here and into the buttons as well, so that when you file down to the edge of the button, they would just revolve. I mean, I cut these out of a piece of 1/2 inch silver steel. I didn't bother to harden them because this was only going to be a one-off thing anyway, but as I said, it didn't really work for me anyway, so I'm going to resort to using the belt sander to do it instead. Obviously it's a lot quicker to do it this way as well. So I'll just show you just one bit of this, because again, you know, these things are so you know, these are quite boring things to watch, I imagine, but anyway, I'll do my best to make a nice rounded end on both bits here. Well, that's just cutting one end. I won't keep you hanging around while I machine grind the other end round, but that's come out quite nicely. And what I'll do is rub this round with some emery paper just to clean it up a bit. But that's quite, you know, this belt sander does give quite a good job, and it's obviously a lot faster than filing something as well. So one of my better purchases. But I'll bring you back once I've done this and can move on to the next part of the job. Right, the next job, you'll see why when I was drilling the holes in this piece, why I made a tiny little witness mark here. And the reason for that is so that when the workpiece is in the vise, set up to my vise stop, I can lock that in place. And then what I did was use the drill chuck with my pointer to line up that little mark. I only needed to do it in one place because it's only really a matter of turning this around against the vise stop, because this feature will be in the same position at each end and on the other side as well. So once that's set, everything's in place. Just gonna clean this tool up and then let's have a go. something on there, a bit more on the brush. And away we go. Okay, that's the first one. I'm just doing this really by eye to get them all sort of roughly the same size. I'm machining that to as near as damn it 3/8. So all I've got to do now is turn that round, bring it up to the stop, tap that down, and we're ready for the next one. No need to sort of make any measurements because that will land in, or should land in it, exactly the right place each time. Some cutting oil on. It. And there we are. Now it's just a matter of turning the part over and doing the same thing on the other side. And I bought this, this is a 16mm ball end mill. I did actually buy this quite a number of years ago for one project I wanted to do. Rather an expensive item to buy, but since having it, I've actually used it quite a number of times. Ever so often you come up with a use for it, so that in the end has sort of paid for itself. This size of cutter, 16mm, is about the capacity of this tiny milling machine. Oh, do you like my nice Japanese soft blow hammer. I treated myself to this the other day because the one I have been using is getting rather worn out now. I mean, I do use the brass end, you can see quite a lot, but I thought that was pretty nice. So that's that feature completed. There we are. I'm sure you know what this is if I do this. So I've still got bits to make to go in here, and that's it. But some bits are quite fun. Really. I quite like using the ball end mill. this tiny part I had to make. You can see it has a little V slot in the centre. I actually filed this out. Not the easiest thing in the world to do, but I think I've managed to get it okay. And then I also had to cut little 45-degree angles on each corner at the end as well. I decided actually to do this on the milling machine, and I'll show you the setup for it. After that was done, I also had to drill and tap a little hole in the end. This is a 3mm hole, but I'll just show you the little setup for this part on the milling machine. I used the method that have actually used, I think only once before, using a small vise in my mill vise, because the mill vise obviously can't be tipped this way to get the correct 45-degree angle. So I lightly clamped this in, and then I used two angle setting blocks, a 30 and a 15, to give me the 45-degree angle I needed. That's obviously then clamped very tightly in place, and then I can mount the piece of material in the chuck, and then use a square to set this up, and then just lock it in place, and then machine across this side, and then just reverse it to machine the other side, to give me the angles I needed on that tiny piece. I've got a piece of 1/4-inch brass bar in the chuck here, and I've already knurled it, but I've sort of over knurled it to give a very, very fine pattern, which is not too sort of rough to the touch, and hasn't increased the diameter of the material too much. I've done this with my index knurling tool. I haven't shown any of this because I've shown knurling with this tool in a video before. If you want to go back and sort of have a look at that, this is a very, very high quality knurling tool, which fits onto the tailstock. So what I've got to do now is I just face the end off, and I've got to drill and tap for a 3mm thread through the centre. Now what I've got to do is give it just a very, very light chamfer and then part off a piece of this to length. Bring the parting blade up. I just changed the camera position slightly so you can actually see what I'm doing, but I've got a small parting tool mounted in the tool post, and I'm just bringing it up to the face of the chuck to make sure I've got it nice and square to the work, like that, firmly in place. What I've also got to do, which I won't be able to see, is change the speed of the lathe down to its lowest for parting off. I can bring the parting off tool in, find my ruler and move that along, and I want a piece approximately 1/4 of an inch long. Lock the carriage and we're ready. Used a bit of folded cardboard trick so that the part doesn't go flying across the workshop. So there we've got our little knurled wheel. I've just got to now take that little pip off that side of it, and that little part is now complete. Well, I guess all is revealed. I guess you already worked out what I'm actually making. This is a tap wrench, and I'm making a miniature version of the tap wrench that used to be made by Eclipse. Now, rather than being the sort of normal type of small tap wrench, that's sort of something like this. I wanted to make this sort of flat design. You already saw me making these parts. It's the little clamp and the little brass screw that will move that along inside of here. But obviously there's got to be something to hold this in place, and you just saw me machine these two tiny pieces of steel. These will be mounted over here on either side. What I plan to do is rivet these in place. And I've already drilled some tiny holes in the sides here. There's a limit to the size that I could do this, because the if you like, the walls here are very, very small, and if I drilled these holes too big, they're going to sort of break into the edge and or even weaken this part of the wrench itself. So the holes here are 1.7 millimeter in size. So what I have to do now is transfer the holes into these little plates which will be mounted on each side, and then rivet them into position. Now, I did try to get some tiny rivets, which I only checked with it on eBay. Nothing really came up that was small enough. The only sort of, if you like, the proper design of steel rivets I could find were about 2 millimeters in diameter, and that would literally have been much too big to go through the sides here. So what I'm actually going to do is use some very, very fine steel nails and cut them down, and then sort of rivet them over on each side. I'll bring you back up a bit later on, because transferring the holes here and drilling them out is, well, I might be able to show you actually drilling the holes in here. It's a bit of a sort of a tedious thing to do, but I thought I'd show you where I've got to so far. The tap wrench itself is 3 inches long. I'm not sure what the actual length of the Eclipse ones were, but I'm guessing about twice the size of this, so something like sort of 6 inches long. In fact, you've probably seen the one that I've used in the past is this one. This is actually 6 inches long, and I made this one a few years ago because I rather liked the design of the Eclipse one. I did try to buy an Eclipse one, but every time they came up for sale on eBay, they were very, very expensive indeed. So I sort of decided as a project to make my own. This one is this part of it's made out of hot rolled steel. Obviously everything is twice the size on this one. And what I did with this one when I made it was to put little cap-head screws on each side so that it can be dismantled. So if there's ever a problem with it or it jammed up, I could take the screws out and take it apart and make any adjustments that were required. This is great to use, actually. I mean, I do use this most of the time when I'm tapping holes. The one I'm making here, this is a steel flat bar EN3, which does machine very, very nicely. And I've also made these little, I don't know what you call them, finger or thumb rests on here, so that when you're, in fact, if I drop that part out, so that when you're tapping, you've got something to sort of hold on to. Anyway, I'm going to move on a bit more, get the hole positions marked out in these. What I'll probably do is just bring you back when I'm drilling the actual holes in there. I might even bring you back while I'm sort of riveting those in place. We'll see how we get on. Well, this is the part of the project where I actually try and put this together without dropping any of the parts onto the floor. You see, I've held it all together with a couple of nails. These will be the nails that I'm using to make little rivets out of, and I've got everything all lined up in the right order. I've already cleaned this off with methylated spirits to get all the marking blue off, so that everything is sort of nice and clean, sort of ready to go together. To make the little rivets, so I've made 2. I should have made more because I'm bound to drop 1 or 2 of these anyway, but we'll see how we get on. What I did was I used this little piece of sacrificial metal here. I mean, I use this actually to experiment cutting this little sort of cup that I cut on the ends of this part as well, just to see how it worked out. And these little drilled holes here were ones that I experimented with to find one which was ideal to use in the finished part, basically. So what I did is I chopped the heads of the nails off and then popped that through the hole here, and then held the bottom part here in the bench vise very tightly, and then peened the end over on one side on both of these, so that it's made sort of tiny little rivets. So what I'm going to attempt to do is pop one of these through here. So if I pull those nails out and try and pop that in through there if I can. Oh, here we go. I've got everything lined up there now, and rather than hammer onto the cast iron anvil, I'm going to use this piece of steel to rest that on while I peen the top of that screw over, that rivet over. So I can hold that so you can actually see what's going on. I'll just get that one started, as the other nail has fallen out already, and pop that one in as well. If I can get that lined up. And now move that round out so you can actually see what I'm doing. That's got it started. And do it round that way. That's it. Yep, they're held in position, and now we can run that through. I've not got them on incredibly square, but I might better jiggle those around to even them up a bit. I'll just see if I can do that. Well, I think I've squared it up a little bit better, so that will hold the clamping parts in place, and as you can run that now in and out. Now obviously this is only really designed for quite small taps, where this one will obviously take much larger ones. Wind that out so you can take much larger size taps, but it's not turned out too bad really. It's quite a fiddly thing to make, but it's quite a fun project really. I mean, after making the large one, it's going to give me sort of two quite nice taps to use. It's been looking in my drawer of tap holders. I've got quite a large number of them, which is always very useful, because if you're tapping the hole using a starter tap and then a bottoming tap, it's handy to have one of each in two different wrenches basically, so that you haven't got to keep changing the taps over. With this new one I've made here, I'll be able to do the same with it, because here's its twin. Rather than just make the one, I decided to make two. The easiest sort of thing to do, rather than make one and then make another one, was to do each process on the two, one after the other. Obviously I only showed one being made. In fact, this was obviously the first one I made. I think I made actually a slightly better job of this one than that one. You can probably see that I didn't get the holes here properly in line, where I made a much better job actually with the first one that I made, and it holds the taps, you know, quite nicely in position. So there we are. That's the end of this this little project, basically. So I think we can now wind this one up. Well, I hope you enjoyed watching this little project in the making. Tiny bit of lathe work here just to make the little brass knob here that will draw the clamp in and out. Everything else basically was done on the milling machine. That got a lot of extra work on this project. So I've got two additional tap wrenches for my collection. So thank you very much for joining me in the workshop again. Got to find another project now to follow this one. So again, thanks for joining me in the workshop, and also thank you to all the subscribers to the channel, and thank you for all the comments I'm receiving. If you've got a comment, you know, but please send it on to me. If you can give me any useful tips or advice, it would be most welcome. Anyway, thanks very much indeed, and bye bye for now.